All right, here we go. This is going to hopefully be helpful to you. These are video solutions to this practice situational problem. High-speed trains, and this is a situational problem involving rates and ratios and proportions, and a little bit of similar figures as well. So your first challenge, of course, when you hit the situational problem, figuring out what exactly are the tasks involved, because you got a whole bunch of information here showing up in a table. You'll see in this problem there's a lot of information in this table that never ends up getting used. You'll see that nowhere during the problem will we ask any questions dealing with the means of propulsion or with the lifespan of a locomotive or the cost of a locomotive. So all that information is there. It doesn't necessarily mean it's important. You've got to figure out what is important to answer the questions that are asked you. Now, one thing always important in a situational problem, as much time as you can afford to invest in reading the problem, you should do that, because often you'll find that in a situational problem, the actual math you need to do doesn't take a very long time to do if you know exactly what it is you're doing. And so you come at the problem in a bit of a panic, you want to go dive right into solving it, and you don't realize that, well, if I actually take another 7 or 8 minutes, which feels like it's time I don't have, but if I take those 7 or 8 minutes to read and really understand what I need to do, then maybe doing the problem will take much less time than if I dive at it without understanding the context. This context here, we've got this guy Francisco who works for the government of Canada. He's got to decide on a high-speed train link between Montreal and Trois-Rivières. And in the table, there's 4 possibilities for him to choose from. Each of these has to go to its top speed immediately. That little fact, to be honest, is just in there to make the problem easier for you. And each train has 1 locomotive. This is something you don't really use, but it's information that's there. So the first problem you have to figure out is just how to list the trains in order from fastest to slowest. This is an equivalent rates problem because you have different speeds for these different trains, but if you look at them, this is given in kilometers an hour, this is in kilometers a minute, this one in meters per second. So in order to compare them adequately, you have to get them all in rates that are in the same units. So you can decide for yourself which rate do I want to use. That'll make that easier. Since you've already got 2 trains that are in kilometers an hour, it's going to be easiest to get all of them in kilometers an hour, which also makes sense because it's a kind of speed that we're used to using. So for this question, what you got to do is get these 2 speeds into kilometers an hour and then compare all 4 speeds and list them from fastest to slowest. That's your job. So let's start with this one. 5 kilometers a minute. I got to turn that into a speed in kilometers an hour. The best way to tackle these is to say to yourself, 5 kilometers a minute, let me start by turning that into a fraction. Say to myself, 5 kilometers a minute, that's like a fraction that has a numerator of 5 kilometers on top and then a denominator of 1 minute on the bottom. It's easy when you see like a unit rate, like 5 kilometers a minute like that, to forget that you're actually dealing with a fraction. And when you remind yourself that you're dealing with a fraction, it makes it a lot easier to get an equivalent fraction, which is really what you're doing when you get an equivalent speed. So you say to yourself, I'm starting at 5 kilometers in 1 minute, and my final answer that I want to get to is some answer that's in some number of kilometers in 1 hour. Because kilometers per hour is kilometers per 1 hour. Easy to forget about that number 1 there. Now that I've figured out where I need to get to for these equivalent rate problems, focus on the denominator. Let that be the driver of what you're doing. I'm trying to get from 1 minute to 1 hour. As long as I focus on that, the top will take care of itself. So this one's actually pretty easy. 1 minute to get to 1 hour. Say to yourself, okay, well, let me multiply this by 60. That's what I'm going to do right away. I'm going to multiply the top by 60 and the bottom by 60. If I multiply the top and the bottom of this fraction by 60, I end up with 5 times 60 on the top, which, let me just put a little equal sign in here. 5 times 60 on the top is going to give me 300 kilometers. I'm just multiplying 5 kilometers times 60. I don't have to think kilometers per hour just yet. I'm just multiplying 5 kilometers times 60 to get 300 kilometers, and 1 minute times 60 to get 60 minutes. That's my denominator here. Okay. Now, actually, because this one's not too bad, I'm almost done. I've got 300 kilometers per 60 minutes. All I got to recognize is I can rewrite 60 minutes to get it to be 1 hour. So I'm already pretty much at the end of my conversion here. I just say to myself, if I can rewrite 60 minutes as 1 hour, and this is in kilometers here, kilometers is what I'm looking for. I've already got 300 kilometers as my final answer. So that's just to tell me that the speed of this train here, that's 5 kilometers in 1 minute, its speed in kilometers per hour, which is what I decided I'd use to compare, is 300. So that means the express here, 400 kilometers an hour, the turbo train at 300 kilometers an hour, the rapido is at 500 kilometers per hour, and that just leaves me the super train. I'm just going to put a little note here to myself whenever I'm doing my work. I want to make sure I know what I'm talking about. This speed here is my turbo train speed. So I'm going to label that. I'd do it more effectively if I wasn't using this paint program, but it's kind of unwieldy, so that's the best I can do for you. All right, so now I'm going to calculate the super train speed. That's the only one that I'm missing. Super train speed. And please get out of my way. Thank you. Super train speed, I'm going to do the same thing. I start off, remember, I turn that rate that I have, 100 meters per second. I remind myself that it's actually a fraction. It's a fraction that has a numerator of 100 meters, and it's got a denominator of 1 second. And then I say to myself, this is where I'm starting. I'm reminding myself that it's a fraction. This is where I'm starting. I want to finish with some answer in kilometers per 1 hour. Okay, so let me give myself a goal over here. I want some number of kilometers over 1 hour. That's what my final rate is going to look like. That'll make it easy for me to compare. Some number of kilometers per 1 hour. Then I say to myself, okay, let me focus on the denominator here. Say, what do I have to do to 1 second to eventually get it to 1 hour? Well, you might be thinking, well, there's 3,600 seconds in an hour. I can multiply it by that right away. It wouldn't be wrong. You'd probably get to the right answer because you'd be less prone to making mistakes than I would. But I'd be a little more careful. I'd say, okay, let me do it step by step. Let me start by saying, okay, I know I have to get bigger. So if I'm starting with 1 second, what's bigger than a second? A minute is. How do I get from 1 second to a minute? I got to multiply it by 60 because that'll give me 60 seconds. So I'm multiplying the top and the bottom by 60. And I know that just because I'm focusing on the bottom. I say 1 second times 60 will get me to the next step. That'll get me to 1 minute. Actually, let me even write 60 seconds so I can see exactly what I'm doing. 1 second times 60 gave me 60 seconds. No way I'm going to lose track of my work there. 100 meters times 60, that's going to be 100 times 6, which is 600. And then I have another 0 on there because it's 60, not just 6. And I want to keep track of my units too, so I'm writing those in. 6,000 meters every 60 seconds. Okay, so far so good. Now the reason I did that is I wanted to get bigger. I wrote 60 seconds, but I know that the whole point of that was 60 seconds is the same thing as 1 minute. I learned that sometime a long time ago. Some nice lady in grade 1 told me that that was true. So I'm going to rewrite this as 1 minute on the bottom. And 6,000 meters, I see my final one is going to be kilometers. I can make this easy myself and say I'm going to write this already as 6 kilometers because it's easy. I might have waited to the next step if it wasn't a nice easy number, but because this works out well, I'm already going to switch that. So now I've got 6 kilometers per 1 minute. I started with meters and seconds. Now I'm not all the way where I needed to be, but I'm already getting better. And again, I focus on my denominator. I've got 1 minute here. I got to get them into 1 hour. So what do I have to do to a minute to turn it into hours? I got to multiply it by 60. And if I'm doing that to my denominator, that means I have to also be doing it to my numerator. So when I multiply both these guys by 60, I end up getting 60 minutes on the bottom. 60 minutes. Just what I was hoping for. Well, wasn't very good at managing my space here, was I? Let me see if I can move this over a little bit more. Here we go. Well, that looks like negative kilometers an hour. I guess that's traveling backwards. Let me tidy that up. Okay. So I multiplied that by 60 to get 60 minutes, which means I do the same thing to the top. 6 times 60 gives me 360 kilometers. That's my numerator now. And you might say, gee, you're sure taking a long time to write it like this. It's always to make sure that I'm keeping track of what I'm doing. I'm not going to go wrong this way and get lost and have some numbers without units and lose track of what I'm doing. I did all this so that it's clear to me that when I do 360 kilometers over 60 minutes, that I can easily assure myself I know that my next answer is going to be right. I'm going to turn these 60 minutes into 1 hour, and my 360 kilometers is already in kilometers, which is what I wanted. So I have actually my final answer right here, that the speed for the supertrain is 360 kilometers per hour. Now I've got a speed for the turbo train at 300, speed for the supertrain at 360, speed for the Rapido at 500, and speed for the Express at 400. So if I want to list the train's order from fastest to slowest, I'm going to say Rapido, Express, then the supertrain, and finally the turbo train. That's question 1.